बेनो बहावत।
हाँ अच्छा अच्छा चलो
जी।
सही। चलें असद, फिर मेरा नहीं ख्याल कि और कोई
हाँ
इंटरेस्ट ले रहा
स्टार्ट
है
कर
इस
लें
सेशन
अभी,
में।
आप
स्टार्ट करते
स्टार्ट
हैं
कर
हाँ।
लें।
तो आई थिंक वहीं से स्टार्ट करते हैं जहाँ हमने लास्ट टाइम हमने था। स्टिल रेडिएशन सेफ्टी का ये एक क्वेश्चन है। सो व्हाट आर द some of the safety features interlocks on a Linux? It's a very basic question. Um, so you just need to name them. You don't need to explain anything. They might ask you later on as a follow-up question, but you can just name them. So what are the some of the safety features on a Linux?
It's ionization chambers,
So let's
monitor unit chamber, MU, is the first safety feature, MU1 and MU2. Then the time, then beam off option is there, then emergency buttons.
yeah.
And also there is sensors are there in the gantry. If it detect any object nearby, so it will stop. That's a safety feature. Last person out is another safety feature for the staff.
Yeah, that's true. So you have mentioned, I think, most of them. The emergency button, definitely the door interlock, audio visual systems. You can mention that CCTV cameras, signages when the beam is on. Definitely, if it is in a, it will become red. So last person you mentioned. So motion. I think you have mentioned most of them. That's it. Sometimes this question is so simple that we are not expecting that somebody will ask this question, so you might get lost during the exam.
Okay,
That you might
I have a comment about this last man out. This is gender biasing, Rainbow. It's not good. Last person out should be.
okay. Last minute.
Why we should left women inside the bunker?
This is a really good question. I don't know the position really. Yeah, that's true. Yeah, LPO, last person out. Yeah, we used to call it LPO. Yeah, true. Yeah, that's true. Okay. So name the 4 main categories of radiation that have to be considered in radiation shielding assessment when your Linux is operating at 18 MV. While doing your bunker assessment for high energy above 10 MeV. So what are the 4 categories that type of radiations that one needs to consider? Anyone can jump in, maybe Naveed or anyone.
We have from the Bangladesh as well, Anwar Islam.
Oh,
Welcome.
Mr. Anwar Islam, I can see. Welcome.
Yes, thank you. Good morning from Bangladesh.
Good morning.
Okay, it will be about neutron detection, neutron assessment. That's the and the door assessment as well. Like the door has appropriate material for the neutron shielding. Or Rangor?
Yeah, these are the 2. Think about
Okay.
something else.
Okay. Else.
Anyone wants to attempt?
Leakage, primary, secondary neutron. Okay.
Yeah, I mean that's it. This was
we should be more basic then.
Sometimes that's what I'm saying. Sometimes the question is so basic that we are ignoring the primary, secondary, and neutrons, right? So they're just confusing you by saying 18 MB. But in 18 MB, there is a primary, there is a secondary as well, right? But there is a leakage, but there is a higher leakage rather than the low energy. So our mind is just getting stuck with the neutrons, right? So that's what they want to trap you there. All right. So a very basic question. What's the beam quality determined in units of for MV photons and kV photons? I'm not sure whether the kV is a part of the IMPCB, so you can ignore that part. But what are the beam quality of determining factors for MV and electrons? Very fundamental. Yes, Usman. How you are saying that your 6 MV is 6 MV, and how you are picking the numbers from your TRS 398? Just make your life easy.
Sir, can you please repeat the question?
You know, your 6 MV and the 6 MV at Arhan or the SIUT may be different, but so there must be a beam quality indicator, right? The protocols, some international protocols. So how you are defining your beam quality indicators for MV photons as well as your electrons?
Imperative.
So for photon, we are defining at certain depth, 10 cm depth. We have a specified number that we are expecting. And for the electron,
what's
what?
that number? What are you doing there?
66.7 something. 66 point.
No, there's the number, but what are you looking for?
Percentage depth dose.
Yeah. If you are using TG651, then that's the protocol TG.
Yes.
But if you are using the IAEA, then what's the beam quality?
Then TPR 2010. So
yeah. What about the electrons?
Electrons is R50. We measure the R50 for that beam quality.
Yeah.
And for the KV photon, I think a half value layer, the filtration is defined the beam quality.
Yeah.
Or also
yeah,
the energy maximum, also the maximum energy.
For half value layers, you can use your KVP in combination with the different filters. That's true. Okay. So here you go. As you said, TPR 2010. If you are using IAEA protocol, if you are using TG51, then definitely is 10 cm depth PDT. And R50 for electron, the HVL for your AV. So they might ask you for maybe a follow-up. I mean, that what's the disadvantage of using the PDD as a beam quality indicator?
What's the disadvantage?
What disadvantage? Okay, both.
Electron contamination on the surface, or
That's true. Why? Because PDD is defined at depth, those at depth and those at Dmax, right?
yes.
Near Dmax, you have electron contamination. That's a very
Yes.
good point. And what's the advantage of using PDD?
Straightforward.
Straightforward. Just
setup is very
right?
setup is very simple.
Yeah, very simple. Yeah. And
But,
in for TPR, yeah.
For the TPR, electron contamination is not an issue on that also?
No, not.
Why?
Why? Because you are taking two measurements at depth, right? At 10 cm depth, there is no contamination.
Okay.
But if TRS 398 is giving you a different formalism, if you don't want to go inside, change the SSD, right? Because for this, you have to put your 90 and that 80, and that needs a time. Right. An empirical formalism is there in TRS 398. You can directly convert from PDD to TPR, which we are doing here. So that's the simple way of doing it as well. If you have given a PDD and you are using
Rainbow, wait a second. Mr. Malik, would you like to say something? Oh. Okay, carry on, Rainbow.
Yes, please, for the rest of the participants, I mean, anyone can answer these questions. This is just a discussion. It's not an exam. We are just learning from each other, right? So if I'm saying something wrong, please just stop me and correct me. The next question is, I'm trying to be quick this time because last time I think we managed to cover a few questions within move a little bit faster. So what's the formula for dose calculation according to the TRS 398 formalism? Explain each term, including the correction to the raw reading that are required. Here, just a clarification that mostly in exam, they are not asking you the mathematical equations, right? But this is bread and butter for a physicist. This everyone should know the formalism, either if you are using TRS 398 or TG51. So therefore, this question is very common, and they might dig into some of the factors later on we will do. So can anyone jump into, because this you guys are using on daily basis? What's the formula?
So,
Otherwise, I have to point out you guys.
Naveed, Anwar Islam, you can answer these questions. Mohammad Yusuf, you can participate if you like. Your voice is not clear. I just background sound is coming.
Hello.
Yes. Yes, speak.
Sorry, I can't hear you.
You can't hear me?
Yes, I am hearing you right now. Okay.
Okay. Would you like to answer the question?
This question.
Yes,
What
it's
is the
written.
formula for dose calculation according to the TRC 98 formula? Explain each them, including the correction to the raw reading that are required.
Yes.
That's mean the dose calculation according to TRC 98. You know that we need the meter reading from electrometer. Then we need to correct multiply with NDW correction factor. This is we get it from debate certificate which is provided from the company, and we need some beam quality correction factors. So KQ cannot we know. So the terms some correction factor we need, because if we data from electrometer, this is influences by some factors like temperature and pressure and ion recombination. You know that we need two different voltages to measure this. In the maximum, the difference should be at least two. So, and also some polarity corrections. Some polarity correction we the electrometer phase in a different polarity may have different readings. So we need to correct the polarity correction also. So, and the K electrometer reading correction part, that is if the sambar and electrometer is calibrated at once. So in that case, we don't need the electrometer correction factors. So if we take the exact meter reading, which is uncorrected, and if we multiply all of them, then we get the exact or corrected meter reading. And the beam quality correction factor, as already you have said, that if you have T per 2010 value, and if you have PDD at different two ratio, from there we can easily calculate the T per 2010 value, and this corresponding T per value we can easily find the KQ value. This is, and that's the same way R50 and from the table TRS 90 we can also find the beam quality correction factor, and obviously NDW correction factor we taken from the certificate, and if you multiply all of them, we can get the dose.
All right.
That's
Thanks.
all maybe.
Yeah, thanks. Okay, let's discuss this one. KQ factor. This is a question that this KQ factor contains 4 other correction factors. Do you know what are those factors? Because mostly we are not dealing with them. Rather, those international protocols that have done that work for us in the background. What's the rationale behind correcting for those 4 of them? Initially, name them 4 of them, and then we can discuss. Do you know what are the 4 factors which are when we multiply 4 of them, we are getting KQ factor? We are used to get TPR, KQ using either TPR or PDD10, but we are not discussing what the KQ factor is basically. So anyone knows those 4 of them?
In the previous session, you have discussed that question.
Oh, we discussed this.
Yes.
All right, no worry.
So,
Okay, let's go ahead. It's fine. Oh, you can, yeah, you can see the previous lecture. Yeah, that's fine. Okay, all right. So what are the 8 tests that need to be done after a 3D water scanning tank is purchased? You have a new water scanning phantom and you are responsible to commission your new 3D tank, and how you are going to do that? Common question, and this kind of question you can, if you answer it in the right way, you can apply to some other commissioning tests as well. It's not typically applicable to the 3D water phantom.
there are connections, there are moving parts, like the carriage is working fine or not, positioning of the chamber, the holders of the chambers, and the filling of the water and the drainage system. The whole system has to be checked before using. And then, of course, we can test with the PDD, with our standard, like we have standard value of our PDD or beam quality of the machine can be verified.
Compare with
What?
your baseline,
Yeah.
you mean baseline data?
Yeah, baseline values.
Yeah, that's true.
And can take the profile as well.
Yeah, you must have some your baselines from your commissioning data you can compare. Okay, that's fine. That's a good idea. Answered, but let's make it in a more clear way that whenever you get anything, you need to check your documents first, which we are ignoring most of the time. That you have ordered something, you need to verify that you have you are getting the same water phantom with the same specs you have ordered for, right? That's the first thing, the documentation. And then secondly, because it has been transported from somewhere else, that you need to do the physical inspection, visual inspection, that is fine, is intact, is physical integrity is there. And then as you discuss rest, water pumping, leakage, and alignments, histresses, all the stuff you mentioned. You will put some definitely a detector, you will see the limits and step size, increase, decrease, and see the effect of changing the step sizes and the speed on the scans. But if you want to refer to a document, then TG 106 is the right document. And one important thing is, yeah, read the manual as well. Cable leakage and whatnot. And then you said you will analyze the data, you will compare with your baselines, whether it's working or not. And some of the softwares you have, they have built-in protocols, right? Some of them, they have IAEA, Electa, and TG double APM. And which one you are using, you need to make sure that it's there and it's working. And one more important check is that you can take in PDD for an electron, which is your depth ionization curve, and then you convert it to PDD and see if it is applying the right formalism for you. Okay. Again,
can you elaborate the hysteresis?
okay, let's do the hysteresis thing. That what you are doing, I can, you can check the hysteresis, that you can put a graph paper tight enough on the both ends of your water phantom, and then you start running your detector from by putting a pencil from one end of your water tank to the other end, and to see that is it giving you a straight line or not. If it is making some ripples in there, then there is a hysteresis, that it's just vibrating. So that's the simple test that those motors are really moving the your chamber smoothly without any hysteresis. Yeah.
Okay, thank you.
Why this is happening? I don't know where these lines are coming from. Okay. Very fundamental question. Anyone wants to answer this question? This is what, when we get a new machine, we do the accept test first and then commissioning. What's the main difference? I need to look how many participants we have so that I can. Come on, guys.
Shazib, want to talk?
Yeah, I don't know who has drawn these lines here. Can you remove these lines? All right, so
Okay, acceptance is a set of tests set by the vendor, and they are sure that what they are delivering is according to the specification, and the physicist is testing that specification. The commissioning is a broad spectrum. It's covering the whole data uh, according to the guideline of what's the requirement of the planning system. And extra data is also acquired for the baseline.
yeah, yeah. If you are typically talking about the beam data commissioning for your Linux, yeah.
Yes.
But this is applicable for all the devices. If you are getting an arc check, map check, whatever you are getting, you can do acceptance and then commission.
Yes.
So with a particular example of the beam data collection, that's true. Yeah. All right. So what's happening here? Come on. As you said, mostly this is done in conjunction with the engineer that you have purchased an equipment which meets all the specs provided by the manufacturer. That's true. And the rest, as per the need, you can capture as much as you can. Okay. Why should the MLC leaf positioning be better for IMRT than for conventional 3D treatments? Positional accuracy, reproducibility is more important for IMRT, while for 3D CRT, that's important, but it's least comparatively. Who are doing the IMRT in your department and with the machines can jump in. I can see Shazeb. I need to look at the list because nobody's. Hello.
Someone has answered on the chat box because the margin in IMRT are too narrow. Answer from Mr. Osman.
Margin.
Hello.
No, the question is not clear. Arshad.
Yes, I think it is because in IMRT there is sharp dose follow, and the structure nearby can get higher or lower if there is more error. Yeah.
Yeah. Because when you are using a modulated fields, definitely the field aperture is defined by your MLC position. And if your MLC position is start reaching the exact planned position, then the doses you are looking in the TPS may not be exactly you are delivering there. But when you are doing a 3D CRT, it's just the field size defined, right? But in IMRT, it's a continuous fluence, it's a pattern, and there is a superimposing multiple fields. And the doses you are getting, the cumulative doses you are getting is the superposition of basically the penumbra, right? So therefore, the position is very important in case of the IMRT. Okay. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So let's skip the KV. So what are some of the basic steps would you do if you asked to review a CT, LINAC, overall QA system? This is you are doing on daily basis. You need to just come on, guys.
You can answer, Rahim.
All right. So definitely.
There's an answer came from Mr. Osman in chat box. Laser alignment, ODI check, KV measurements.
Yeah. All right. So look at any QA program. We are straight away jumping into the basic test which we are doing on daily basis, right? We are not talking about any recommendations, consultation with the staff, because different departments have different needs. At the same time, you cannot develop your own things, right? If you're not, you have to do an evidence-based practice. The first thing is definitely the literature review, what protocol says. If you are implementing a QA program in your department for LINAC, then definitely TG 142 is the right document. You will look at it and you will consult with the staff what is required, what is not, and what equipment you have in the department. And you will review your current TG, your QA protocols. If there is an unnecessary steps you are doing, if those are redundant, there is no need, you can remove them and do the risk assessment. If I remove them, what's the risk? If you want to add something, you will add something. And one more important thing is the trend as well, and the tolerances and the reports and the findings. What are your findings? What are your trends? So these are the things you need to look when you are talking about the QA program in any LINAC or a CT. So the RTs have purchased a new breastboard. And what are the 8 main tests that should be made before it's ready for the clinical use? Just like this is a breastboard, is in the department in charge to do the commissioning before using it clinically. What you will do? Now this is becoming a kind of lecture instead of a discussion. Nobody is coming up. I don't know what's happening today.
Like
Come
it's
on,
a
it's a very
simply
simple.
a visual inspection first, then the connecting of each and every component is right. Then mechanical check, like there's a alphabetical and the degrees are given this equipment, so you can verify those angles and whether they are going to those angle or not. Elevation is right or wrong, and we can verify the elevation and the attenuation for the beam entry. If the manual calculation is done, or if we are doing a CT, then we can verify its Holmes field number. It's coming right or wrong with the manual as well. But my question is, do we really need to have a breastboard nowadays? We can cover it with the backlock easily. There is no need to lie the patient in uncomfortable position. Like I believe that this breastboard is quite uncomfortable for the patient.
Yes,
Backlock is much
you
better.
can. Conventionally, the breastboard has been used and is still in use. Just like here, we have the backlogs, but still, it's a good question. For some reason, I don't know why they still use the breastboard. I don't have an answer for that. But just for the sake of, from the exam point of view, as you said, you will find out dimensions. You will see the compatibility of the CT. If you're using it, if there is an artifact, you will see indexing is important. Uniformity, as you mentioned, surface doses, and whatnot. Yeah, I mean, these are some of the things you can check before releasing the breastport clinically. And now your center wishes to move away from performing measurement-based quality assurance tests on IMRT patients. So list 5 steps you would perform to implement. Current practice is to put a device, do the measurements, patient-specific QA, give a report. But if you are moving away from measurement-based, so how you are going to do that if you have been asked to do that?
Like we can do mucal check
Yeah.
or without measurement. Independent TPS.
All right. This question is the first part, as you can see, in different countries they have a regulatory requirements to do the patient-specific QA. Just like where I'm practicing, they have we can't treat at any cost without doing the patient-specific QA. So it depends. You will look at, first of all, that is it the regulatory requirement in the where we are practicing? If not, then you can move on, right? If it's a regulatory requirement, there is no way. Then you will also do some literature review, that is there any center in the world that are doing this and how they are doing this. You will do some literature research. And then the second important point is that you will see the trend QA results, that what are the chances of that your plans are failing on that device, right? And then you cannot straight away jump and say that let's quit the QA program for all the sites. No, it's not possible. You will start with simple anatomical sites, one at a time, starting from very simple cases, and then you can move towards your head and neck complex plans. And definitely you have to run in parallel your current practice and a non-QA base, as Asad said, just the calc, red calc. And then you will train rest of the staff for the new setup which you are doing, non-measurement base, give them training how to use the software, and then you will document, and then you can gradually implement. So in radiotherapy, it's not advised to adopt a new practice all of a sudden or shift from one modality to another all of a sudden. It should be gradual. From the literature, they have found that jumping into something new is risky. Again, these questions are very simple. You guys are not answering. Your center has just received some new bolus, 1 and 5 millimeter thick. Can the RTs use the new bolus straight away or not? If not, why and what you will do to make it clinical? Yes, Usman. Shazeb. So many.
We have a professor as well today. Dr. Atif Masood has just joined.
Oh my God. Sir Asif. Yeah, Sir Atif is also there. Yeah. But it's beyond the scope of Dr. Atif's. So someone else can jump in.
So
This the bolus.
we can do the QA simply, check the bolus whether it is water equivalent or not. And
how you will do that?
By placing the bolus on water phantom or solid water phantom, take the reading and verify it, like a factor.
What kind of reading? What do you mean?
We know about the solid water, for example. We just place the chamber, take the reading, and then place the bolus and take how it should be same, ideally. The reading should be same, but if there is a difference, it will reflect that how its density is different from.
Will your CT simulator will help you?
Yeah, we can do the CT as well and check on the TPS as well.
Yeah, just the house fields, right?
Yeah,
And,
sounds good. The both way.
doing the CT will help you to determine the house field plus if there is any non-homogeneity plus if it is producing any artifact and even the dimensions. Yeah. So the question is, the answer was that you need to commission. And for that, as you mentioned, you introduce a new concept that we can do that. I mean, because if it's water equivalent, take the readings in the water. There's something which is good. But the simplest way is to do the CT scan and check the thickness and the density. Yeah. All right. If no issues, then definitely we can just straight away use. Those who are doing definitely the 3D CRT still, it's a very relevant question about the reference points. And they have specifically mentioned in the ICRU. So categorically, there are those 4 points when you are keeping your reference point, or you may call it the normalization point. Asad, I know you answer, but can anybody jump into this? Definitely, I know 50% of our centers are still doing 3D CRT.
No, right now in the Pakistan, most of the PAC hospitals are doing IMRT.
No. Are we not doing 3D CRT?
3D CRT is reduced. Number of patients are reduced in 3D CRT and overall Pakistan.
No, just okay.
Switching and the VMAT, IMRT, they are frequent, quite frequent.
Okay, we are not discussing them from exam point of view. Okay. All right. So, but these are some of the points mentioned that whenever you are normalizing at a certain point, you need to take care of few things. That definitely you cannot keep it in where there is a beam penumbra. You cannot keep it under the in a block. You cannot keep it where there's a density gradient because we can, if we are using really a Monaco treatment planning system, we have found that it's really good at modeling the beam, but because this ICRU report was published long time ago, and we found that using Eclipse, especially when there was a PVC, the system was not capable enough to really give you the good doses if you are not keeping your normalization point where there is a gradient, there's a steep dose gradient. So these are some of the points. So the point is that the point you are planning system should be unambiguous. You should give a point in XYZ orientation perfectly defined, and the recommendation is if it is in the center of the PTV, that's good. If possible not, you can keep it outside, but it should be away at least 1 cm from your field edge. And you can see. All right, so what are some of the factors you need to consider when determining the optimal calculation grid voxel size for photon dose calculation? Okay, we can put it the other way around. That in your department, who has decided to define the grid size in your department? Just like I remember we used to put 0.125 in Eclipse for no reason, I don't know still. So what are the reasons?
And I think there is a trade-off between the time calculation time and the results. Like ideally, we should choose the lowest grid size to get the finest dose distribution or spatial resolution of the doses should be fine. Especially in SRS, we nowadays is like 0.1, I think we are selecting, or 0.125, or I think. So it's we need to be more finer in the specialized treatment modalities. But we can go with the 0.25 on 3D CRT. There is no issue with that.
Yeah, as you mentioned, which is a very good point in terms of the accuracy and the time. Yeah, you have to keep a balance.
Nowadays, the GPU was installed in most of the systems, so they are speed up, whether you are choosing a lowest grid size. So we can go with that as well.
Yeah. So you cannot put something where you are getting results which are unacceptable in terms of their uncertainty, right? So that's true. Okay.
Again,
Good.
the side specific is also important. Like if you're dealing with the optics, then of course the higher resolution will play a big role. But if you're dealing with the pelvis, I don't think that high resolution is much required in the pelvis.
Yeah, you're right. I mean, stereo versus conformal. Answer is lying here. I mean, if you are dealing with, 1 cm, 2 cm tumors, and your optic chiasm or your brain stem is sitting next to it, and they are so close, you have to be careful, right? And if you are getting very off nearby, so you have to decide your grid size in such a way that the system can really model the doses with certain level of acceptable accuracy. True, that's good. But if you are really doing a big IMRT model involvement, just you said in pelvis, then it doesn't really matters. Okay, so you might have seen all these issues because of the. So what are some issues that respiratory motion causes in radiotherapy? Why?
You can miss the tumor. We have to take more margins to cover the tumor due to the respiratory motions. If we don't have any gating system, there is an answer from Shazib Naeem, image blurring while doing the CT, I believe.
Yeah.
And the dose
Seems
to
like
OR.
today's Shazib and Usman's mics are not working. Shazib, you can answer why you are typing.
True, he said true. Your mic is not working.
Oh, okay. All right. All right, let's do it. So yeah, okay. Let's go ahead. Let's go to the answers.
Aswan says same with me. My mic is not working.
All right. So definitely the tumor delineation, right, is the first thing. If your images have been taken and you don't know which phase you have taken, your controlling will be wrong. Then ultimately your treatment planning, you will be planning on that delineation and the deliveries will be wrong. So everything is wrong. As I had mentioned, normal tissues, definitely because of the motion, they are coming in the way. And the one more important thing is that, other than which is mentioned here, is that motion interplay effect, especially if you are doing small field IMRTs, like your Saber cases or in SRS. That's one of the reason the concept of dynamic conformal arc therapy is in there both in Eclipse and Monaco, especially for Saber lung. People don't like to modulate the planes for lung cases because it's moving organ, and if you modulate that motion art effect, interplay effect, motion interplay effect is going to play, and you will be looking very nice isodose lines in your system, but in reality it's not going to happen on the real patient because you are doing your QA with either with the film which is again static or you're again statics, map check static. You may get pass your results, but in reality it's not going to happen. Conformal therapy for lung cases is one of the solutions because it just follows the tumor. When you delineate the tumor, you are not the PTV, rather you are delineating your ITV and you are encompassing the medium range of the motion. What's called, there is a special term, maximum intensity projection. You are taking inhale and exhale in all the phases, and you are taking a medium scan, and you are incorporating the motion, and then just straight away put the DCAT plan. Then you can because this can be a follow-up question, how you are taking care of such emotion, how you are reducing these effects in your clinic. Answer that way. Okay, I'm not going to this is very basic. I'm sure that everyone knows this. Okay, let's come to again radiation safety. That what are the basic steps you and the other present staff would take in an emergency of interstitial HDR situation where the source failed to retract? This can be applicable for even HDR, cervix, whatever, but this is particularly for interstitial HDR situation.
Well, if there is a beam off button, first we press that, and the emergency button, of course, at the console. But if both the fails, then we should go inside along with the survey meter, and we should have a clock to set up to record the time, that how much the personnel is going and spending the time inside the bunker when the beam is the source is out. Then we hit the emergency button at the wall, and if it's failed, then of course we have some hand crank in the different machine, and there is a different phenomena in different machines. The Flexitron has different thing on the afterloader. I don't know exactly the name of that. I don't remember, but there is a system mechanism to retract manually the source. And the last option will be if it is not again working, then we have to cut the applicator or cut the guiding tube and put it on the container, lead container.
Yeah,
that's
so
the worst case scenario.
Worst case scenario, the last option. Yeah, that's true.
And
okay,
also the time management is also there. Like the one personnel is not supposed to spend all the time inside the bunker. We can shift with the RTT, the physicists, and the doctors. And the drill is very important. Before that, the drill is important so that everybody know their function or the work they have to do during the emergency.
Yeah, I mean, yeah, that's true. Use of the stopwatch. Sometimes we are ignoring this. We have seen this. We are not really doing this practice. Very difficult. Even we used to even not use the survey meter, the console. So, but if you really follow the instructions, standard instruction that Asad mentioned, you can start your answer by saying that I will definitely follow the departmental radiation safety plan or the emergency plan in our department, and then you can list what you have mentioned, which is very good. And there's one of the reason that there must be RTT, RO, and the physicist and the extra backup and the everything, because there is a limitation that one can around with the source, live source, for a certain time, right? So that you can your doses can be within permissible limits. So they can go into a little bit deeper that for how long a person can what's the permissible limit in case of an emergency. The figures really I don't remember the figures, but they are mentioned in one of the ICRU 103.
The rule of thumb is if the source is 10 curie, you can spend less than a minute to get 1 millisievert. But if the source is activity is lower, then of course you can increase your time, but it's not good practice. It should be less than a minute or a minute.
Yeah, that's true. Some of the common methods, two methods are mentioned in TICDoc 1274 IAEA TICDoc document to find out the air karma strength for your HDR. I remember we used to do using the well chamber. I'm not sure, maybe I remember Dr. Atif back then when we were doing a training, he used to show us the brachytherapy, QA, and all the stuff. I still remember that hands-on part of that training. There was a workshop. Asad, I hope you remember that. I think we are doing
in
using well chamber.
2011,
I'm not
in
sure.
2011.
Yeah, long time,
Yes.
Dr. Asif.
In Kiran Hospital.
Yeah. I'm not sure whether we are doing in-air methods or not, because I'm familiar with the well chamber. This can be a common question. That's how you are verifying your air current strength for your new source. What are the two methods, and what are the advantages and disadvantages of both? If you don't know the in-air method, is fine. So what?
In the lieu of time, Rahim,
Mhm.
you can answer these questions in a quick mode so that we can
Okay,
complete
let's.
this session in 5 to 10 minutes, I believe.
All right, okay, no worries. So basically, yeah, if you give a reference to this one, that's, as I mentioned, it's mentioned in TechDoc 1274. That's a very good document. You can go and read that. Given you two methods. One is the well chamber. The method, if you are doing HDR, then you know that when you get your source, you get a certificate with certain readings and when it was manufactured and the date and transition time and all the stuff is there. So then you will find out, you will make your setup, you will find out the sweet spots for your well chamber where there is a maximum gain, and then you will route the readings. That's the way of doing it. If you don't have the well chamber, people can do with using in-air method as well, using the calibrated former chamber. But the problem with the former chamber is that there is no direct calibration for former chamber under iridium 192. So they are using basically 60 and 250 kV energy, and they use the interpolation method to get the calibration factor. But the problem with this is that the setup is difficult to achieve. It's reproducible setup, and there are 4 uncertainties which are mentioned in TechDoc 1274. You can go and read. Therefore, people not recommending. This is if it is failing on a well chamber. In Australia, there's the way they are cross verifying with their available former chamber. So, what are the main goals of the HDR program? So definitely the most important thing is the safety of your taken to the hospital, and therefore you have your door interlocks, you have independent radiation monitoring system. One is with your console, right? It gives you when the source is in and out, but you have independent monitoring system as well. Intercom, radiation monitors, time accuracy. And the second thing is in brachy, we know that how important it is to reproduce the positional accuracy because of the those fall off outside the source. 1 millimeter can change a bigger, can implement introduce a bigger error because of the inverse square law, right? So similarly, the temporal accuracy, dosimetric accuracy. So all the things are important in brachy. This is what I was talking about in the document. I will show you these 4 uncertainties which they have mentioned about the in-air method, that we know that the former chamber has a certain dimensions, and the beam is a diverging beam. Beam hits the former chamber, then there is a non-uniformity across the former chamber. I mean, it's intense in the middle, and when you go away from the periphery, then definitely the beam intensity is less. So this non-uniformity is an issue. So you have to keep your source away from the, keep your chamber away from the source. That increase your scatter. And the second is the position. If you are not really putting your chamber exactly where you are putting, then there is again, because of the inverse square law, there is a lot of uncertainty, the leakage and the calculation uncertainty. As the best compromise they have given is that you can use in-air method at a 16 cm, which is the recommended value given in the TechDoc 1274. So describe 2 methods for improving catheter delineation in CT. Would these help to delineation the MR? Yeah, so the field of view, reducing the field of view can improve your pixel size and orientation. Orient your chambers in your treatment planning system, and then use your library, or you can reconstruct them manually. And window leveling can also sometimes helps, because those applicators can produce artifacts and which can give you the wrong dimensions. Therefore, it's better to change your contrast and set in such a way that you know the dimension of your applicators and insert them in the I mean use your applicator library or what. So HDR brachytherapy can have a high chance of accidents if the quality assurance programs are not implemented. What are the daily checks needed before each treatment? So we know that for every brachy we used to do the QA. So the best document is to go to the TG56, and where we are checking definitely the door interlock, the last man out, emergency cutoff, must have scissors and the spig in there, and the audio video, all the stuff you can't ignore. Although this is redundant, but you have to do this, and every time you have to check your dual positions. And whatnot. This scatter is not you are thinking of. This scatter is that while doing the in-air measurements, how you can find out the scatter factor. So there are two ways. The first is that keep your former chamber at one distance and measure the value, and put it at other distance and measure the value, and do the same with the inverse square law. The difference will be because of the scatter, definitely, because in mathematics there is no scatter, right? So that difference can give you. The other method is that you can take a reading without any shielding between the source and the chamber. This is your source, this is your chamber. Take a reading and put completely a shielded material in there. And if you are still getting a reading up there, it means there's the scatter which is going through the walls and you are getting a reading. And the ratio will give you that scatter factor. So these are the two methods to find out that K scatter while doing the in-air methods. So if you guys are doing your prostate permanent implants, one of the basic question is that the ultrasound is the major imaging modality, and TG128 is the right document to go through and do your QA. And they have given a list of tests which are pretty simple to do. The first thing is definitely your distance scaling. You check the linearity and all the stuff that is giving you the right scaling. If the prostate is 5 cm in left right direction, it should show you the 5 cm, right? It can't show you something else. And then the area, and that you are finding the area and the volume of your prostate. If so, you have the QA and delineate and find out, send those images to the TPS, measure the area and the volume. And if you have a noun value for that simulated QA phantom, then it should reflect in that your similarly the grayscale accuracy, volume accuracy, depth of penetration, Excel, all these tests are mentioned before you implement any ultrasound-based prostate permanent implants. This is internal shields for the eye. There sometimes you have to use the internal eye shields for the electrons, for the lesions which are sitting next to the eye. But we have to be careful in terms of the selection of the energy and the thickness of your lead because of the backscatter and the production of the Bremsstrahl. So these are the things you need to consider, how you are going to reduce your backscatter with internal shears by using a low Z material coating, and what is the thickness, what should be the thickness of your internal eye, keeping in view the feasibility as well, because you cannot keep a thick eye shield in the while doing the treatment side. So all those feasibility, there is a report as well to use them in but one of the, you cannot use greater than 9 MeV when you are treating the lesions next to the eye, because to shield to keep the thickness transmission of the 9 MeV, you need the thickness as a rule of thumb up to 4.5 cm millimeter of your lead, right? So which is not feasible for eye. You can't keep it there because of patient. It's not possible, and you need the extra material to shield the backscatter. One of the small field dosimetry. that how you can measure up to 1 by 1 cm field size, right? So this is the small field, and for that, the protocol for R3, they have given you the methods that how you can go up to 1 by 1, and they have given you the techniques. Either you can do the daisy chaining, or you can just use the output factors, field specific, machine specific, chamber specific, and field specific output factors. Go there and just you can do that. But mostly people are doing the daisy chaining. We don't have a time. What does mean the daisy chaining? You can go to the protocol. It's a very simple technique by introduction of an intermediate field using your calibrated chamber at 10 cm, and then 10 by 10 field size, and they choose a small field size up to 5 by 5 or 4 by 4, and then do the daisy chain with your small detector, and then apply the formalism given in the protocol. So scattering for replacement. So once you do your scattering for replacement, what are the tests one should do? Asad, do we have still time, or we can? It has 1 hour now, so maybe people might get saturated. So if I'm talking and you are muted, now. You are still muted.
Yes. Well, we can, complete this thing. Just one more question, and then we can conclude.
Okay. Everyone knows the importance of the scattering file, right? So if you think logically, then it will be easy for you to answer this question. What's the function of the scattering foil in the head of the LINAC? Then you can see. Definitely you will be checking your symmetry profile, radiation field sizes, right? And then one thing which we are missing, I'm not sure centers are doing, at least at Khan when I was there, we were not doing the radiation field sizes and the flatness and symmetry at various cardinal angles as well. Maybe because of we don't, at that time there was no profiler. So but the practice is that, because even you can see the effect of the magnetic field is changing as you go around the different cardinal angles. Therefore it's recommended to you check all the your field sizes, radiation field size versus your field size at different cardinal angles as well. Definitely then you compare your commissioning data. You have to set the baseline. If you have changed, you must have a baseline, measure it, compare to baseline, and the rest factors, cutout factors, whatever, just take some of the subsets and compare. This question, I think if you have read Khan's book, that he has described very well, that the change of the surface dose as you along with your SSD and the field sizes. So here the important that usually here in Australia, at least they love to ask you this question about the different behaviors of photons and electrons in terms of the buildup, that why the surface dose increases as the energy is increasing for electrons, which is other way around for photon. So you need to give them the explanation in terms of how electrons are scattering at wider angle and all the stuff, and there is a ratio of maximum dose to the surface. It's a mathematical explanation. You can go there. Okay, I mean we can stop here. You can think about this question, that usually I'm not sure that how we are optimizing our protocols, because I don't think so. Do we have any DRLs? Because at that time I was not aware of, because we installed one of the CT at Ziauddin, and at that time I was there. I was not aware of there is any need for an optimization. We use just the protocols given by the Siemens. So, but the good practice is that you need to optimize your CT. If you have a local DRLs, you can use them, and you can optimize in such a way that you get the maximum good image quality at the same time giving the low doses to the patient. So this on that. What is the optimization? How to optimize? What's the principle? Definitely, the simple principle is that the ALARA, and to explain that ALARA, how you are going to explain, is the below that. What are the parameters mathematically? If you what is the relation of the KVP to your dose? Is it the square or in the linear? Similarly, the MAS, increase in MAS will affect what? So it's similarly the pitch. So all these, if you know about KV, MA, and the pitch, then you are good to go. And especially even the that if you go to the CTDI measurements, then definitely, and the DLP, then the scan length is also one of the parameters. So while optimizing your CT scanners, you have to keep in mind all this stuff. All right.
Okay, thank you very much, Rahim Gohar, for your time. It's very valuable questions or valuable time that we have with you today. We will join soon again, and I hope you will prepare for the other session as well.
Yeah,
Like,
I hope for the best, guys, for your exams, for those who are preparing for part 3. The advice would be, whenever you if the examiner is asking you a question, don't answer straight away. Sometimes there's our practice that if we know a single word, we just straight away jump into. Take a break, pause, and think about it in a wider spectrum, and make your mind that definitely you are there for part 3. The examiner knows that you know the stuff, but he's looking at a wider spectrum, that how you are handling these questions. Are you officially, or your thinking level is a little bit deeper? If they think you are safe and your thinking spectrum is a bit wider, then nobody's going to fail you, because they're not expecting you to answer 100% everything, but they want to make sure that your thinking level is, your approach is safe. That's it. All right.
okay. Thank you very much, all of you who has participated. And the recording will be shared soon. Thank you.
All right. All right, guys, bye.